Forecasting is like trying to drive blindfolded and following directions given by a person who is looking out the backside. Technology is the application of science or art. We define technological forecasting as the process of predicting the future characteristics and timing of technology. When possible, the prediction will be quantified, made through a specific logic, and will estimate the timing and degree of change in technological parameters, attributes, and capabilities. It is not an attempt to predict how things will be done, nor is technological forecasting oriented toward profitability. An innovation has traditionally lagged the invention by 5 to 7 years. Once the innovation is developed, its adoption is also not instantaneous, often taking between 10 and 20 years to reach the point of market saturation. The lag between invention and innovation and the time required for adoption are useful for the technological forecaster. He can consider the possible nature of innovations before they occur and assess the innovation before actually adopting it. The major techniques for technological forecasting may be categorized under two general headings: methods based on numeric data and judgmental methods. This method is applicable to forecasting functional capabilities. Statistical procedures fit the past data to mathematical functions such as linear, logarithmic, Fourier, or exponential. The best fit is selected and extrapolated. Here is a manifestation as to how statistical curve fitting can be used. For example, we can forecast pole position speeds of race cars by plotting them against time measured in years. Let us consider the post-World War I era. As these speeds increased exponentially, two technological innovations have been the main reasons. One is the rear engine car. Then, that is in 1961, qualifying speeds were about 150 miles per hour. The second technological innovation occurred in the early 1970s. It was the use of sophisticated aerodynamic devices, that is, wings at the rear of the car. It essentially created downforce, thus increasing cornering speeds from 170 miles per hour in 1970 to 179 miles per hour in 1971 to 196 miles per hour in 1973. These are popular numerical data based techniques. This growth curve forecasting method is particularly useful in determining the upper limit of performance for a specific technology. An example of growth curve analysis is shown in the following figure. The above figure depicts the number of telephones per thousand population as a function of time. The year in which the upper limit of diffusion is reached can be extrapolated from the S curve, and it occurs between 1990 and 2000. Extrapolation in growth curve cannot go beyond the saturation level of one specific technological approach. It cannot predict a decline or future rebirth of the growth pattern. They attempt to describe a future technology or technological event together with its environment. The scenario is a hypothetical view of the future based on past experience and conjecture. Scenarios may cover any period but generally extend 10, 20 or more years into the future. They start with a set of givens. These are then massaged and extrapolated to give a picture of future technologies. Three scenarios are often developed. The first describes the future if current trends continue, and this defines a base for the other two scenarios. The second and third scenarios describe optimistic and pessimistic futures based on assumptions about the environment that differ from the first scenario, giving a best and worst outlook. Scenarios deal with world events such as famine, war, or environmental destruction. Scenarios are also useful for forecasting the results of adopting a technological change.